Hello and welcome to another video from sicmaths.co.uk, where you can find the whole of GCSE Maths explained on video or for free, and find some amazing revision guides there. This video is about constructions and loci, basically using compasses. Okay, so this is a compass, a metal compass by the way, because metal compasses are the ones you really want to use, and always use a short pencil as well. Metal compasses have better hinges, and they tie better with the screw. All compasses have a screw there that tie the hinge properly, but metal compasses are best, and they're less bendy as well. Don't use plastic ones. Okay, that's a little tip there. So what are constructions? Constructions are just things you make using compasses, and loci are boundary lines that locate certain areas. Like this is a boundary line, and these are this is a boundary line, or a loci, locus. By the way, locus is just a singular for loci. Loci is a plural for locus. Yeah, so basically you mean the same thing. They're just boundary lines. Okay, these are another boundary lines as well here, and this boundary line here, all created using a compass, and they tell you where certain areas are. Like this line here tells you all the points are in equal distance from these points here. Okay, and stuff like that. We'll go into detail when we go into each of these particular examples. And anyway, so let's begin with the most basic thing you need to be able to do, which is create a perpendicular bisector. So what does that mean? If you've got a line here, this line here is a perpendicular bisector to that line, because it's bisected the line, cut it in half, two equal parts. So this length here is equal to this length here, as you can see by these double dashes, which means this length equals that length. And not only does it cut it in half, but this line is perpendicular to it. Perpendicular means to be 90 degrees to it. Okay, so how do you construct or use a compass to make this perpendicular bisector? Hopefully there's some clues in these arcs, these curvy lines. Okay, what you do is you put the sharp bit of your pencil here, and the pencil bit, put the sharp bit of your compass here, and the pencil bit over there, and if you wanted you can make a complete circle, but it's kind of messy and unnecessary. What we intend to do is just create arcs, which are tiny bits of circles. So I make a bit of an arc here, and I make a bit of an arc here, and I just make sure that my compass is spread so the sharp bit and the pencil bit are more than half the distance away. They're spread more than half the length of the line. Okay, because what I'm trying to do, actually, just so you can see in advance, I'm trying to create these crosses which are halfway between these 2 points. So this cross is halfway between here and there, and this cross is halfway between there and there. And to do that, you need your compass spread more than half the width of this line. Okay, so I make marks here using the sharp bit of my compass is there, the pencil bit does this and that, and then I put the sharp bit over on point A, do the same sort of thing, keep the compass the same width apart as it was over here from B, as it should be from there to there, and you make nice curvy lines there. You've got two crosses, connect them, and you've got your perpendicular bisector. Very simple. And let's talk about the locus part of it. I've constructed it using a compass, but now let's see what it can tell me. It tells me all the locus of all the points equidistant from A and B. That means this is the boundary or the line that defines where all the points are that are equidistant from A and B. So any point on this line is an equidistance from here to there, from A and B. So pick a point on the perpendicular bisector. That point here, for example, is an equidistance from here to there as it is from here to there. Okay, so that's your perpendicular bisector done. Let's bisect an angle. So imagine you've got an angle here between lines CD and DE. Okay, what you need to do first to construct this, to bisect the angle, by construction, okay, is to open up your compass, okay, and put the sharp bit of your compass there. Your pencil should make 2 arcs, so this arc is the same distance as this is from that corner, so don't change the width of your compass as you do this, and then move the sharp bit of your compass there, make an arc there, do the same from the other side, sharp bit there, pencil makes another arc there, keeping the compass the same width apart in all these situations, and therefore you get a nice cross, and then make a dotted line or a line, whatever, from your from the corner of your angle here all the way through the cross, etc., and you basically bisected your original angle, which was between the 2 lines. So this angle is equal to this angle, and your job is done. So you've bisected the angle, you've bisectioned the angle into 2 parts. Bi comes from bicycle, you know, from 2. Yeah, bicycle means 2 cycles, 2 wheels. Yeah. Anyway, you've bisected the angle. And again, it ties into the word loci or locus. Yeah, locus is a singular, as I said before. Basically, it tells you all the points, this line here, that are equal distance from CD and DE, which are 2 lines. So all the points on here are equal distance from this line and this line. So you can see there's 2 different techniques. If you want to find points that are equidistant from 2 points, you make a perpendicular bisector. If you want to make a line that tells you all the points are equal distance from 2 lines, you bisect an angle. Okay, so what do I mean the equal distance from 2 lines? Well, if I pick a point here on this locus here, if I look at the perpendicular distance, or the shortest distance to this line, okay, so from here to there is the shortest distance to the line, okay, that is equal to the shortest distance to that line, okay, or the perpendicular distance to that line, okay, and so that's that. What's next? Constructing all sorts of angles, but we will talk about 60 degrees to teach you the principle. Basically, you create an equilateral triangle, which is very easy to do. If you've got a line to start off with, okay, of any width, okay, then you spread your compass so the sharp bit is over here and the pencil is on the other end of that singular line. Then you make a nice long arc until it passes halfway between this line, so the midway between this line, which is above there. You know roughly where midway would be, yeah? So you make your arc going round like that, and then you put the sharp bit of the pencil there, and so the sharp bit of your compass here, and then the pencil bit going round like that, and what you get is a cross on the top. Connect them like this to make a triangle, and you got an equilateral triangle, because you made sure, hopefully, that you did not change the width of or the spread of your compass as you did it, yeah? Because this distance has to be equal to that distance to make it equilateral, so you don't want to change the spread of your compass. Anyway, so you got an equilateral triangle, and of course every angle in an equilateral triangle is 60 degrees. So you've constructed, or you used a compass to make a 60-degree angle. Now that's just the principle of making an angle. You can make some other angles based on that. For example, if you bisect this angle, then you've got 30 degrees, and or otherwise you could construct a 90-degree angle by making perpendicular bisector, or bisecting that angle here, and you get 45 degrees. So you're not really expected to make any angle, just very specific kind of angles are easy to do or make by construction. So that's that. A bit more loci work. It's all constructions really, but not very clever constructions here. For example, if you've got a Chinese takeaway and an Indian takeaway, any of the Chinese takeaway delivers up to 2 kilometers, so maybe you've got a scale on your map, so 2 centimeters, you don't want to draw 2 kilometer circle, do you really? So imagine 2 centimeters equals 2 kilometers, so you draw a 2 centimeter circle there and a 3 centimeter circle there, because that's 3 kilometers. This area represents the locus of all this line, I should say, represents the area or the locus of what C delivers to, or where C delivers to. And this is the locus of the area I, or Indian the indentate delivers to. And of course this area here, or this boundary line here, is the locus of the area both of them deliver to, because obviously you can see that, can't you? Anyway, and finally an example just to demonstrate one more idea, and by the end of that you should have enough tools in your head to do any of these construction or loci questions. Obviously I'm not going to show you every single tiny example. The rest of them just depend on your common sense, but I'm just showing you the techniques that you can build on to answer pretty much any question. So finally, you've got a dog on a lead, a 3-meter lead. Okay, you've got a wall. Okay, and we're looking from a bird's eye point of view or a plan view. Okay, you've got this point P where it's the lead is connected to. Yep, so this is where the lead is, this is where the dog is at the end of it. Obviously the dog can squeeze the rope in, but when it's outstretched, this is the maximum area it can cover. Now the point of this, which is slightly different to this, is that you can see it's got a nice big circle, but then the circle tucks in and makes a smaller kind of circle. Why? Because basically as this lead goes round, as the dog goes round, okay, this part of the rope tucks around the corner of this wall. So 1 meter of this 3-meter lead gets attached or pressed against the wall. That means only 2 meters is left to swing round. So it makes a tinier curve than this one does. Okay, so just to get an area of an idea of what's going on when you're constructing or making loci. So of course this is the locus of the area the dog guards, this area here. Okay, and that is basically it.